Today, we're going to be going over integration. So integration is the opposite of differentiation. So integration, in the question, you're given something like the gradient function, such as this. And using the gradient function or using this straight line in this example, we can then generate, for example, what the quadratic function is. So integration, we are going to go from the straight line or the differential function to the integrated function. So rather than differentiating, reverse the operations. So to differentiate, we multiply by the power and reduce the power by 1. Box yellow is something we've done before. So this is our answer. Some of you find this a bit confusing, so let's do this in practice. Let's say if we've got 3x squared, we multiply by the power. So we take the 2 and we multiply it in front. So we have 6x. And then in order to reduce the power by 1, we take the 2 to a 1 and x to the power of 1 is just x. Now integration is the opposite way round. So we start with this and our end process is to get to this. We increase the power by 1 and then we divide by the power. So you can see it's like a flow chart. We're going completely the opposite way round. So let's say we have a function which is x squared. To integrate it, what we do with this is, first of all, we add 1 to the power and then we divide by the new power. So we add 1 to 2, which is 3, and then we divide by the power, which is 3. And actually, you can see that if we take this integrated function and then differentiated it, we'll get back to this question. So if we differentiate the green, so let's say dy by dx of the green, we bring the power down, which is 3x, and we reduce the power by 1, we're going to get 3x to the power of 2. And it's going to be over the original denominator, which is 3. That simply simplifies to x squared. So you can check you've got your answer correct by differentiating your integrated answer and see if you get your question. So let's go over this question then. We need to integrate 6x squared. So the first thing you do is you take the power, which is 2, and you add 1 to it. So 2 plus 1 is 3. We then take the 3 and write that as our new denominator. So simplifying, 6 divided by 3 is 2x cubed. Now, if we were to check this and we were to differentiate the 2x cubed, we would get back to the question again. So dy by dx of 2x cubed is going to be 2 times the power, which is 6, and then reduce the power by 1, which is to the power of 2. Excellent. However, this is not the complete solution, because what happens if our original function was 2x cubed plus a constant? You know that when we differentiate, the constant itself disappears. Or, for example, we could have 2x cubed minus 3. So what we're going to say here is that integration is a little bit more complex than differentiation, because when you differentiate something, it gets rid of a constant sometimes. Therefore, when you integrate something, you're not taking into consideration this constant. So our answer should actually be 2x cubed plus any constant, because we don't know whether there was a number in the original function. There might have been no number, and that's fine. So we would actually write our answer as 2x cubed plus c. So whenever you integrate, if you don't understand this white process here, just remember you need to add c to your answer. So this is our overall answer, 2x cubed plus c. If you'd like to pause the video, you can have a look at the extra information here. This is just what I've gone over, c being an arbitrary constant. So this is the general rule which will be given to you in the exams. However, I would just remember how it works. We need to add 1 to the power and then divide by the new power. This is how it works. So let's do this for the first example. 12x to the power of 5. Now, before we move on, I just want to clarify something. This symbol here, which looks like a squashed S, is integration. So you might want to pause the video now and copy down this rule, or copy it down in your own words and write down that this symbol means integration. The reason why it's indefinite is because with our answer we get a plus c. In future lessons we're going to talk about definite integration. So with this one then we're going to add 1 to the power, so the 5 becomes a 6. So we get the following: 12x to the power of 6, and then we divide it by the new power, which is 6. Then you divide the numbers. 12 divided by 6 is 2. So our answer is going to be 2x 6 to the power, not to the power, plus c. This one's similar. 8. We're going to add 1 to the power. Now, if it's just x, that's going to be our answer. Because here we have got no x given in the question, so we need to add an x. And because when we add an x, the new power of x is just the power of 1, we write over 1. Therefore, our answer is going to be 8x plus c, our constant. Last but not least, let's have a go at this question. We're going to add 1 to the power, x to the power of 4. Then, what we're going to do is we're going to divide by a new power. So we have our original denominator, and then we also incorporate our new power, which is 4. So it's going to be x to the power of 4 over 8 plus c. Now, like before, I would like to differentiate each of these functions in green, just to double check our answer is correct. So we take this, we're going to differentiate it, so we do 2 times 6, which is 12, 12x to the power of 5. If we differentiate a number, it disappears. Correct. This one, let's differentiate 8x. 8x differentiated is 8. Correct. Finally, let's differentiate this one. We are going to have 4, because the power comes in front, x to the power of 3 over 8. 4 over 8 simplifies to 1 over 2, 1 over 2 x cubed. Now please note that 1/2 x cubed is exactly the same as x cubed over 2. Now this looks a little bit more complex, but it's not. In this mathematical sentence, we have lots of different terms. We have 1, 2, 3, 4, and all you need to do is treat these terms one by one. So you need to integrate the first term, the second, the third, the fourth, and then add a constant of integration at the end. So this explains how we do it. Effectively, what you have is if you have a sum of terms, you need to differentiate the first term, then the second term, then the third, then the fourth. You don't really need to write this rule down because I don't think it's very useful. I would just remember that if you have a sum of terms, you need to differentiate them one by one. So I've split them up like this. You don't need to do these extra workings in the exam, but you might find this helpful. And this is what you get. You increase 3 to 4. You put the new 4 on the denominator. You increase 2 to 3. You put the new 3 on the denominator. You increase power of 1. It's like a silent power, you can't see it, to 2. You put the new 2 on the denominator. If it's just a constant, you just put an x in front of it. Because it's x to the power of 1, you put it over 1, and anything over the power of 1 is insignificant. It doesn't change the number itself. So we can erase any annotations here, plus c. Now, that's almost our answer. All we need to do now is simplify our answer. So we do 8 divided by 4, we can simplify it. 6 divided by 2, we can simplify it. So we get 2x4, 5/3. Now, you can either leave it as it shows above, or you can change it to this. Please note these are the same. You might want to note this down. This one changes to minus 3x squared, and this one stays the same. So as I was explaining before, just differentiate one part at a time. So how is this example different? So the first thing you need to do is rewrite the question. And I'm going to rewrite this in blue. You want to get rid of anything which is a denominator because that's confusing. So I rewrite this as 2, and note you can write the integration symbol like this. It's fine if it's a little bit more spread out than squashed. Now, anything which is on a denominator, when you move it up to the numerator, and we went over this in D1, becomes a negative power. So let's differentiate this. First thing you need to do is you need to add 1 to the minus 2. If you think about a number line, we have minus 2 on the number line. If we want to add 1, we're going to get closer to 0. So therefore, we become minus 1. So this is why this minus 2 becomes minus 1. Then, what we would like to do is to create a new number in front. And I'm going to do another line of working out because I think this will be easier than what you can see on the screen. So we are going to take the power, we're going to add 1 to it so it becomes minus 1. And then we're going to create a new denominator, which is we move this new power as our denominator. Now, what's happened here is they've absorbed the 2 and the minus 1 together. 2 divided by minus 1 is minus 2. So you can do that on your calculator and you will realise that the 2 and the minus 1, 2 divided by minus 1 is going to be minus 2. So this is where they've got their answer. And then last but not least, they've then removed it. So they've changed the x to the minus 1 to minus 2 over x. So you can do that or you can just leave it like this if you prefer. Let's go over 1 or 2 more examples. So this one looks a little bit more complicated. Now, if you have x and the square root of x, this means x to the power of a half. So let's write this down. 3x to the power of a half plus 2. Now, x is on the denominator. So when we move it up, it becomes to the power of minus half. We are going to integrate it here. There's one set of working out here, and I'm going to do another set in blue. The first thing you need to do is you need to add 1 to the power. Now, this is a skill you need to know. If you have 2 over 2, that's 1. If you have 3 over 3, that's 1. 4 over 4, that's 1. So you need to analyse the denominator. The denominator is over 2. So we need to do 3x to the power of a half plus 2 over 2 because that is 1. Similarly, we're going to do the same for this. 2x to the power of minus half plus 2 over 2. If you can do this in your head, excellent. Then divide it by the new power. The new power is going to be 3 over 2. The new power of this is going to be 1 over 2. Now, there's a quick trick when you are integrating and you have a fraction on the bottom. You can either put into your calculator 3 divided by 3 over 2, and that will give you your answer. But what I do is I take the denominator of the fraction and I move that up to the numerator. This is how dividing by a fraction works. Again here, you take the denominator of the fraction and you're going to move that up. So this 2 moves up here, so we do 2 times 3, which is 6. X, we've already worked this out to be 3 over 2. And then we still haven't used the 3 on the original numerator of the denominator. So we write down the 3 here, plus, move the 2 up, 4x to the power of a half. And I don't need to write it over 1 because anything over 1 is just the same. Now the 6 divided by 3 is 2. So this is why we get our final answer as 2x 3 over 2 plus 4x to the power of half plus c. Last but not least, this question here is to do with a bracket. And maybe next lesson we'll go over something more complex. With a bracket, what you need to do is expand out the bracket first and then differentiate the three terms as we've done before to find your answer. I hope you found this video useful.